features without invading privacy, right? Maybe we can use and utilize some kind of exploring. But anyway, I keep as what Parker and Dylan agreed. I will keep recording our lecture and keep posting the lecture in after each class. So that's what I will do. So, but I will figure it out more about this like AI summary thing, and but I'm sure they share those information with the company, whether that is not violating our university property things. I need to figure it out, but lecture recording will be always there. But before we get started with um, the stats discussion, all right. So I just heard so much concern around the campus and around the state and even across the nation. All right. So there's a lot of issues related to what you can say and how you need to reserve something you wanted to say, all right, at this moment. At our university, I have been busy talking to some people on our campus to make sure when we let, faculty go. For example, if we terminate them in their position or when we kick our students out of our campus, I think we should take a proper procedure, not like incident decision. It happened today and tomorrow you're done. It's problem. Okay. So, lately I have been busy with dealing with some of those issues. So what I wanted to say is that there is also a lot of changes and amendment in school policy. So, for example, how we supposed to do about some of gathering on campus, right? Who can do and how you can do, what kind of tools you can use. So just to be aware, there are some changes and the term they use. So, for example, expressive activity. It can be defined in a variety of different ways, okay? How the faculty members can accept, but may cannot accept at a university level because that might not align with the state government policy. So just be aware there are a lot of changes going on, but the important thing is always the faculty members on your side. Okay, if you need to say something and you needed to speak up about something and always just be you and speak up, but at this moment in this climate, I recommend you guys to talk to the most trustful faculty you believe for your opinion, okay, before you really publicly express yourself on campus. All right, so before we settle, before we really make sure this process is proper or not, in order for us to protect you, okay, just talk to your most trustful faculty member. Okay, so especially just last week, there's a new amended policy about the campus, uh, how we supposed to let people use our property to speak up and talk about their view. There's a new separate item. It came out as anti-Semitism. Okay, but my major is also political communication, so I wanted to make sure it was more of the top-down policy from federal government and then state government, and now in our campus. So there are like categories and items about preventing and discouraging hate speech. And then it's somehow pulled up from there as anti-Semitism as a separate item. It is the new amendment made it last week. So what I want you guys to see this world is do not just accept the what really was politicized in a way. I want you guys to understand that, especially Dylan and Rahul, your research topic about is international conflict. And as a political communication scholar, I wanted to make sure if you disagree with Israeli government, especially its government, I mean military action in Gaza, it's a different thing from anti-Semitism. But the state government and federal government and some media outlet, they just kind of politicize it as the same thing, but it's a different thing. Okay, so be clear and be critical and know what you're doing. All right. So we are not always just being silent and being silenced. So we are thinking and we are just we try to figure out what is the best thing for our students and for our community. All right, but just as such a student here, you guys can make differences. All right, so before you really speak or act anything, all right, think critically. Okay, what you're talking about, the information you perceive, it's not the holistic information. It is fact- fractional of information and fragmented information that are somehow framed in a lot of different ways depending on the sources. Okay, so that I wanted to make sure you don't really fall in um, unnecessary or unfortunate situation when you know like a time like this, we didn't really settle with a lot of ongoing issues yet. All right. So I want you guys to stay, just continue what should be your priority, which is learning and get more education and just make this world as a better world. Okay. All right. Other than that, just a brief keep up with just checking on you guys about the next stage of the project you are doing. So basically, Dylan and Rahul, just like a grace, you guys will write up if you want to develop as a thesis, right, to graduate and for this program, or if you want to use as your part of the term paper for another class, or maybe just as a writing sample to move to the uh, doctoral degrees or whatever the reason is. I wanted to make sure I can just help you just to be efficient. All right. So regarding the next stage of a project is the literature review and visiting different scholarly work that are related to your research prominent. So my just a checking point at this stage, Rahul, and you're still looking for some of the studies out there and some data availability. Do you have any new source or any update you want to make?
I'm still searching for like data, but I have made a list of the literatures that I read.
Okay, yeah, good. No problem. As I mentioned that maybe we can have extra, time. So I want you, as I mentioned that on Tuesday, let's have about a week to see whether you have alternative data set you can use it for your research. Okay, but otherwise, may we want to come back and on maybe the end of Thursday, I mean Tuesday class next week, may we want to modify your research question. Okay. And Dylan, do you have any question? And I think your research question can be okay, narrower or just you can still a little bit away depending on some variables we have from the secondary data set. But do you have any question at this point?
I don't really have any questions at this point. I'm still kind of looking around for like sources. Like I guess we're gonna keep doing that, but I don't know how I want to constrict my questioning. But
Not
but
yet. Yeah, of course.
I'm kind of just figuring that out. So
Good, good. So exactly what Dylan said, just try to figure out and how may outline my research and to get to my hypothesis. This is the purpose of the literature review. I ask you to summarize at least 14 studies out there. Okay, so that is somehow Grace done over here with me, but just I want to check at this point. Okay, so let's get started with. Let me record. So you don't have a problem watching once you just log in with your Texas State, you can watch the lecture recording, right? So recording in progress. Okay, so following and continuing from what we discussed on Tuesday, as I recommend that I want you guys to read chapter 5, 6, and 7 forward. Okay, so after, if you're done, that's great. And after today's class, until the end of the weekend, I want you guys to read from backward. Okay, chapter 7 and 6, and then 5. The reason is that, oh, why we are doing this as a part of the foundation of statistics. Okay, I want you guys to just to see the reason why we are doing this. All right, so especially today, we're gonna, as I just briefly mentioned that on Tuesday class, we're gonna kind of switch back and forth. What we are doing in statistics, we are dealing with group of people, right? The samples. In statistics, we really rarely deal with one single case or one single subject or just one case, right? So statistics is all about what we are getting from the group of sample. So from there, we can make interpretation, right? So that is a statistics. So today, what you're gonna do is that from Tuesday class, we looked at, oh, there's like a distribution table. Most popular and widely used distribution table that had a corresponding probability. So having that probability, we can make a sort of a meaningful discussion how likely and how unlikely that specific case could be, so we can make some inference with the value. That was what we did. But when we do, that was with the one single case from even the practice question, right? The single case, and how the single case in terms of the overall distribution. But think about it. In real world politics, you're not dealing with the one case. Not only Dylan, not only Rahul, but maybe group of students in statistics course, for example, right? So we are dealing with a sample. So that's some big kind of a bridge we need to cross. You need to always remind yourself that we are dealing with a group of people as a sample, not a single case. So that is why we need to make some of the logical connection. Why instead of standard deviation, but standard error? Okay, that is a conclusion. So we covered what is standard deviation, most standardized versions of variability we use for descriptive value. But that is about only one single value, right? Of a single case we so far covered. But from now on, okay, what about when we deal with a group of people as a sample? Okay, so then standard deviation become standard error because the unit is not a single case but multiple group of people. So that's what we're gonna cover today. It's the main thing. Once you get that, you're great. You're done. All right. And then as the time allows, because kind of switching back and forth between a single case and group of sample, there's nothing much I can show from SPSS. So instead, if we have some tiny time left at the end, I want to show you how you can manipulate some of the original variable to make an index variable, for example. Okay, if we don't have enough time, then I will include that some data management skills to other Thursday the practices. But anyway, that's the plan for today. So let's share my class note here. Right. Um, So let's just talk about, maybe you already know about simple random sampling, okay? And statistics, unless there is some specific research question, you ask about only very specific people in a specific location for reasonable reason. Otherwise, you can think about 99% of statistics. All the samples are randomly selected, and those random samples are hopefully most representative sample of your research population. Okay, so simple random sampling is a sort of a foundation of the statistics. Okay, unless there's some specific cases. Okay, um, so if you like ANS data set and GSS data set, they're all random sampling, and hopefully it is reflecting some of the socioeconomic, variations in our society. What about across different ethnicity group? What about across different income? So they're randomly selected from what the scholars and these surveyors think it is important to represent general population of the United States and the society. Okay, so the basic principle is the same. Okay? So everyone in our population have the same chance and same opportunity to get selected. Okay, so older days, what how they used to, now with all sort of media, I'm sorry, I'm thinking statistical. I just taught my media courses. I kind of keep saying media. Okay, like any statistical statistic software. Um, they actually had managed to select. If you go SPSS and select random cases, they will do. And how they do? Simply based on all those lists in the random number and case number, just to kind of rotate with the random chance for all samples. That's what they do. Okay, they do. Here, when they do for survey, okay, one step, you know, ahead of, before you get at the secondary data set, they just have maybe older dates, the list of the phone numbers, and then select randomly. So that's all about the sample randomness. Okay, more in the representative, um, group of people to understand your research population. So that is the basic foundation of any statistical model. Okay, um, any statistical probability distribution. So far we covered the only one, which is a normal distribution table, right? On Tuesday, that's what we did. So let's talk about sampling error. Okay, so sampling error, we can just actually, we were here in this slide before. Whatever you do, you try to find the mean value. You try to find the sum of those, one of those, maybe for example, standard deviation. Okay, I showed you this slide, and this it's actually from textbook. Um, when we talked about variance, okay, how much you try, do your best to find the best set of the sample for your research. There's no way you get a completely fair, completely closer to the population. So there is always the gap between your sample. Here I said a sample variability, but any sample values versus your population values, which is defined as parameter, population parameter. We don't know the population value. It's just idealistic value. We don't know. We just predict with the sample values, statistics, right? You remember the definition? So any of those gap and unknown and something missing, we call that as a sampling error. So whether you believe or not, statistics is to find the sampling error. Based on that, admitting, okay, here, admitting it, then you go from there to provide some sort of a conclusion. Okay, so sampling error is just gap and discrepancy and some of the missing information, unfilled information between your sample statistics and actual population value. Okay, so whatever you do in statistics, there's always a sampling error. So do you remember maybe watching television polls, like a news poll values, and they say, well, this is the percentage of people and with the margin of 3%, right? So margin of 3%, that's a sampling error. If any news organization and news coverage say so, that's they done good job. But most of the media polls, they don't talk about margin because the margin is too big. What they try to argue is not really meet with, for example, as what we discussed like first week and the beginning of the second week, when you say like predicted and the percentage was 52%, but your margin of error is more than 5%, then you can really argue it's a majority, right? It can go to like 5 point down from 52, can be 47, right? Then it's not majority. So it's very important to understand and find sampling error and understand it, and then we can go from there. Otherwise, there's no statistics, okay? No statistics. Okay, so moving along, let's talk about there is maybe some concept we talked about today. It can be confusing. I would say sampling distribution and sample distribution, it can be confusing. But at the end, the purpose is clear. Okay, we want to understand general, the statistical distribution. We wanted to use those distribution probability for prediction and estimation with understanding those sampling error. All right. So let's talk about one at a time. The way we did, how we actually got to standard deviation. Discussion here worked, okay, and there didn't work, and then so just all stepwise. So distribution of a sample. Here I said a sample mean, but it can be sample proportion or something else. All right, whatever you wanted to use, like a sample median, for example. That's okay. But when I say here, just let's stick with the sample mean, since as long as it's unbiased and there's no outlier, maybe sample mean is the most sophisticated value. Cover all those cases in your sample to compare, right? So what is the meaning of distribution of sample mean? All right. So again, understand the purpose of it. All right. Let's say Grace, collect some information, from Houston area, and we got the sample mean. All right. And Dylan, before he moved here for the education. Okay, so welcome. And but he wanted to get us some the values from somewhere Middle West, right? Is it right? That's no Middle East. The Mid East area is sort of the center of the United States. Okay, center of the states. Then how the meat look like? Maybe Rahul, he's already here. He wanted to learn something, so he got the information from the Texas. So let's say we collect all those as a sample mean and put that in the distribution. Okay, as what we discussed numerous times, and so build up normal distribution table like that, right? So distribution of a sample mean is putting those sample means in in the distribution, see how that look like, okay, in the long term. So now we have only three researchers, but if we have like thousands of researchers, right? Somehow there will be some patterns of those most reliable values, right? Maybe Grace and Rahul's values are somewhat related, but it's maybe a little bit far away from the center of the mean for whole nations. But maybe Dylan's mean value might be closer to the national value, right? Something like that. So that's what we talked about distribution of sample mean. Eventually, to understand what I want to just in the statistics we say, yeah, Dylan's result from the sample it's a more reliable because it has a more probability based on all accumulated research done. You know what I mean? Compared to what Grace and Rahul collected Southern Center part of the United States. Okay, something like that. I'm not really biased anything, but just it's example. All right, we sometimes it can be much neutral. Something we can found from the Texas is maybe the most representative value. I don't know. It just depends on research topic and the variable you collect. So having that, okay, how we really have the value of sampling variability. Okay, so once you have a distribution of a sample here and there, we just kind of dots all everywhere. And then we wanted to, like the way we done with the normal distribution for each sample mean, what is the probability? How you can do that? Like a coin flipping. Once we done this same experiment and same study numerous times, we know the probability to get a head or probability to get a tail is 1/2 or 50% or 1 point, over, just 1.5 in proportion. So we know based on the numerous practice we do, sampling variability it's built on that same practice. So sampling distribution is probability distribution, the way we saw normal distribution table. So each z-score, statistic value, and there's a corresponding probability. There will be multiple probability distribution. From now on, we're gonna cover beyond the normal distribution, but like a t-distribution, f-distribution, and chi-square distribution. It's all sampling distribution. By knowing where that statistical value of your statistics stands on, you can make interpretation or inferential statistics. Okay, so that is the purpose of distribution. Now the unit is not any longer as a single case of grace. It's like a case of our class or a case of Texas or a case of the United States, something like that. So units are now bigger. It's micro to from micro to macro. All right. So let's see how we can really build all different types of sampling distribution by repeated applications. So let's just use the same example of the coin flipping and just to see how you can eventually can find probability for each score from that experiment, that exercise, or that research, whatever you want to put. Okay. So when we collected, for example, the Grace sample from Houston area, we still without this sampling distribution that are already established by previous scholarly work or whatever the statistician done in creating distribution, sampling distribution table, we don't know whether Grace value is valid or Grace finding is statistically significant or not. All right. So understand that the purpose is to find whether Gray's result is statistically significant or not. So for that, we need sampling distribution. You got that? Okay. So in order to predict the error, what you're gonna do? So you do sample certain, sample size, and then do, for example, let's say sample mean, sample, sampling distribution of your sample mean. Then you store that in the dotted in distribution. And then also another group of people do the same thing and dotted in the result section, and dotted it all like a space of the distribution. Eventually, you ended up with some around some value. There are a lot more probability, and some of the extreme, value, there will be less of probability, right? So, for example, um, let's just think about you have experiment. If you flip coin 4 times, okay, and how you can build sampling distribution. It's a very much simplest way you can understand about different sampling distribution. So let's see if you flip a coin 4 times, okay, so there will be all head, head, tail, head, and whatever the order is, right? So that's all like if this is simple enough, right? 4 times, it's gonna be all 14 possible outcome, right? So how you can find the sampling distribution for the exercise of, coin flipping for 4 times. So basically, you keep doing it the way we practiced and we talked about the summer camp in Michigan. Just universally done, amazingly, and stuff. It's not surprising. It's as expected. As the sample size goes up, the real experiment number is closer to theoretical value of 50%, 1 over 2, 105 for coin flipping. So numerous exercise. And also we ended up, right, all the tail out of 16 times, 16 occasion event, there is one chance. If it is 16 times, or if there is only 3 tail or head, but it's a much better chance, like a 4 over 16. So once you counted how many times, it's a total times of the trial and how many times you really get the number, and then you put in the table. This is the probability table, okay? And then by the numerous trial, this is the actual probability you got, right? And then you put that in the distribution. In this case, it's more of a specific value, but a lot of cases, most of distribution table had all continuum of the scale. But you can actually make sampling distribution with this experiment. That's how you're gonna make a sampling distribution. You got that? Okay. So not from a single case, but group of the sample size. Okay, so that is a sampling distribution. That is what we need. So when we say, okay, Grace, this isn't the number you got, let's put it here, see what is the probability. Okay, so your probability is this high, and we prove your study. Or you disprove, we disprove your study based on this sampling distribution. You understand logically what we are doing? Okay, great. So, right. Now we want to move on to let's jump over from one single case we dealt with and just variability test, standard deviation. Then okay, now we are dealing with a group of sample, and we still need to find those sampling error. What is that? The same thing. The standard deviation to be average sample. I'm sorry, average distance from the random case to the the sample mean. But now we are thinking about the real world statistics. So sampling error by definition is, so what about your random aggregate sample statistics, how the value are far away from the population value? It is best estimated. So the units are group of sample versus a single case between standard deviation and standard error. But we are looking at the same thing. But in real world, statistics, we are dealing with a standard error, not standard deviation. You got that as well? All right. We just covered the standard deviation because that is really how they come up with how variously, how widely they are spread around the distribution. But now your sample, how they are doing in real world knowledge. That's what we are dealing with in statistics. Okay. So standard error is how your sample statistics are spread over, over the sampling distribution. When we have a collective collection of the sample mean about the same research question about the same thing, right? So standard error is the value we are gonna use for statistical analysis. Okay, any inferential statistical analysis. So, okay, again, this is not really formula. I repeated it maybe 5 or 6 times already. I don't know whether you recognize or not. When I say standard error, standard, sampling error, and it's all about the sample. All right. So remember, this is the sigma. This is the notations that we use for standard deviation. All right. But in the real world, the standard deviation is from the mean, how your specific case is away from the sample, your sample mean. But now you are dealing with how, as a group of a sample, it's different from general population. So only the difference is whether you have a single case or multiple cases. That's the differences between standard deviation and standard error. So let's say you have a single case, you plug in the sample size here, one, standard deviation and standard error will be the same. You got that? Automatically. And then if you have a two sample size, three sample size, and four sample size, now your standard deviation will be will gradually decline, right? Gradually narrower. That is a great thing. Since in statistics, a lot of times, if you have a larger sample size, it solves a lot of problems. Okay, less error, less mistake, and more reliability with a narrower margin of error, right? So large sample size. So basically your error term gets smaller having larger size by dividing by square root of a sample. Okay, so statisticians, okay, why square root of a sample? If you ask me, okay, it's again more of a normative. It's not mathematical decision. It's just more of those such subjective matters. Well, rather than raw value of sample size, but that's not the purpose. We wanted to deflate our error by increasing sample size. So deflating it, but it's like not dramatically, but somehow in a theoretically reasonable way, they determine the square root of sample size is better than raw sample size. Okay, so that's what they decide. Okay, it's not any scientific decision. You got that? Okay, so you totally disagree with those early statisticians. I'm okay with that. I'm totally fine with that. But this is how they decide. Standard error is the average distance between your sample statistics and the population mean value. Okay, so using that, you can now say, with a margin of 3%, 4%, or 0.5%, this is what the number we got. So it's how reliable this is. Okay, so that's statistics. So that is what I'm saying here as the foundations of statistics. Okay? All right. So any question up to this point? Any question? Good? All right. And then again, there's some points you needed to, okay, why we divided by square root of sample size? Do I need to memorize it? No. Just understand why we are doing it, right? So we wanted to show the audience that as the sample size increase, your error can goes down, right? So that's what they try to show. And rather than a single case, when you're dealing with a multiple case, your error goes down. That's what this formula try to show you. Okay. So that's it. And I think I already explained it. But let's say there's no variability at all. Okay. No variability means you have a sample value. Your sample value is a population value, so that is why there's no variability. There's no error. Unless there's always a variability. Unless standard error, there will be always some value. Okay, not zero. But if you have only one line and one value of standard error without any variability, that's not statistics. Okay, you got that? So let's say you have same standard deviation value, but if you have like 100 cases or 1500 cases, let me show you. Okay, this will how it look like. Okay, so with a much larger sample size, your sampling distribution is much narrower. The bell shape, but much narrower, much less variability. But if you have a sample size of 100, so it's more widely spread out. It's less concise, but still show the probability. So larger sample size tend to be more reliable, more efficient. Okay, so you're predicting something right here. Maybe with the sample size 100, yeah, that's there, but it's with a lot of probability. But if you have this probability, so right there, oh, that's like already 70% of the chance. So it's much convenient and efficient to make statistical conclusion with a larger sample size. Okay. So here, before we move on to SPSS, maybe practice, I think we have some time to do so. Let me introduce one of the most fundamental, foundational theory in statistics. Okay, central limit theorem. Okay, and assuming that all the samples or most of the statistics is random sampling. Okay, at the end of your research, to make a statistical conclusion, okay, it's all about central limit theorem. Okay, so regardless, okay, your sample distribution, your sampling distribution. When I say sample distribution, it's all the cases there, but sampling distribution is aggregate values from your statistics, whatever is a statistical sample mean or sample proportion or even sampling error. What is the probability, right? That's the sampling distribution. So as long as you have some sample, have a sampling distribution, it always ended up your sampling distribution from whatever whatever the researcher to collect that. And whenever they done, however they done, sampling distribution always ended up as a normal distribution. Really? Yes, it does. Yes, it does. Okay. I will come back to this, but let's just see. I still from the textbook here again. Let's say this is the original population sample, distribution. Let's sometimes like really, American voters are equally say all the way from the smallest value and largest value. They say same thing. Just totally to square. Just all same values across all the range. Okay, that is a population sample. I'm sorry, the sample, what we collected for population, we put it there, right? But it's also theoretically and how it looks like by based on what we know theoretically. And then let's say you just in order to collect that sample to represent that, to understand this population thing, right? You collect the sample 2, 5, and eventually 30 and sometimes 1,000. What's going to happen is that, okay, for example, Grace is the sample values right here. Okay, so from that, you collect and make one aggregate value as a sample mean. Put it here. And Dylan's sample value is maybe right here. Put it here. And maybe Rahul's value somewhere, aggregating this together and maybe somewhere here. We put the numerous value and gradually, you ended up normal distribution. Eventually, from that and at least different sample 30 size, 30 of them research done, and eventually your probability for sampling distribution is somewhat like that. And started with your population distribution is a bimodal or negative, or maybe really already just normally distributed. As the sample size goes up, because you collect whatever this original population distribution in order to put as a sample statistics, as a sample statistic value, whether it's mean or median, it ended up as a normal distribution. And sometimes, like already normal distribution, closer to a bell shape, it will be more quickly converted as a normal distribution for sampling distribution. That's a central limit theorem. So basically, we can use normal distribution table for your statistics. You understand what I'm saying? So central limit theorem is eventually your sample statistics can fit in normal distribution to find the probability, how good and how bad, whether it's statistically significant or not, using normal distribution. That's a central limit theorem. So especially your sample size is over 30, case of sample 30, and it all ended up with a normal distribution, and thus you can use normal distribution table to answer your statistics, the final answer, whether it's statistically significant or not, based on the corresponding probability. Not a single case. So we practice on Tuesday by the end of the Tuesday class, right? And how your single case compared to the probability overall is more likely or less likely. We already practiced that, but now we having sample group of sample aggregate value, we can tell whether your statistics is the value is valid or statistically significant based on central limit theorem. Okay? Any question here? So although maybe you think, oh, now I completely understand, or well, I'm still not quite sure, I will repeat as many as times I can. Once you read forward chapter 5, 6, 7, and then backward to 7, and 6 and 4, 5. Okay. The reason is that because whether you believe or not, you deal with a big thing, kind of crossing from a single case to multiple case of a sample. This is one of the most important foundations of statistics. You got that? Okay. So just, summarize before we move on. Population distribution. When you hear about population distribution, we don't know really because we don't have every piece of information about population. It is just a population distribution based on the knowledge the best guessed information from cumulated studies done. So it's more of an idealistic, the best guessed information. That's a population distribution. Okay. What is a sample distribution? That we try to repeat multiple times, making sure what we collect is really closer to what we theoretically believe is a population distribution. So we collect trace sample and put it there in the distribution. And Dylan's sample, put it in the distribution. Rahul's sample, put it in the distribution. That's a sample distribution. And from that, me as more of the people who collect that, all multiple studies done and how they have it done, I can finally, okay, Grace sample value had across all these like thousands of studies done had a probability of 60%. Dylan had a probability of 55%. Raher's statistics has a probability of 5%, for example. That's sampling distribution. Okay, that is a sampling distribution. You got that? All right. So this is really what I wanted to cover theoretically, and just in order to make sure what you're dealing with, the way we did on the Tuesday class. Just let's see how you can really convert your statistical brain from a single case to multiple case. Let's actually do a couple of practice question before we move on to SBS as a practice. Let's go to page number 214. Sorry, Grace, that you don't have the textbook, right? But we can read it and you can kind of just estimate. And it's not many times we're gonna do. I will just do for this week and possibly next week to use the practice question. Just to make sure we really make this theoretical connection. That is it. All right. So Dylan and Rahur, if you go to the textbook again, the big statistic textbook, not handbook. Let's go to page number 214. 214. And then if maybe Rahur, do you have a textbook with you? Would you mind if you read learning check question number 1 for Grace so we can be all on the same page? So on page 214 and learning check question number 1.
Just a minute. I only have ebooks.
Okay, ebooks, it takes you time. Okay, then maybe you can try to be there while Dylan can read it for us. Okay, Dylan had the hard copy one. So are you there already on page 214?
Yes, and just question 1.
Yes, please.
Okay. For samples selected from a population with a mean of 100 or a standard deviation of 15, which of the following has the smallest standard error? A sample of n.
No, it's fine. It's just up to that point. Thank you. So it's very similar to what we have done practicing on Tuesday class. So it was on Tuesday we talked about what about like is the actual case value 85, right? So we dealt with the one single case, but now here they're talking about samples, right? So this is what we do in real world statistics. This is a chapter 7, right? Why we do chapter 5, 6 because of chapter 7. Why we really do single case reading the book from 7 to just backward. You will see why we are doing this. So now we are dealing with a sample. So in order to have a small least standard error, in other words, margin of error, that is necessary for statistical test. Okay. In what situation we have small least standard error? Standard error is standard error and standard just deviation for the sample. When we can have a small least error, of course, when we have more sample size. So the answer is largest number of sample, which is in this items. The 4 cases, 16 cases, and 25 cases. The answer is 25 cases. And oh my God, why you ask this question? It's a logic. So basically, in order to reduce those errors for the sampling distribution and sampling error, increase your sample size. That is the question they ask. Okay, maybe I'm sorry, just if I ask that, Dr. Yun, you really ask this kind of a question? Yes, I'm sorry. Okay, but what I want to emphasize here, more sample size, less error. Is that clear? Right? This is a statistics in decision of what they tried to do. So let's say, Rahul, are you now on the page 214 on ebook? And can you read the question number 2 for us, please?
Yes. For samples selected from a population with 40, that's
Mm-hmm.
mean, right?
Mm-hmm. Just
And
some population mean over 40. Yes, good. Very good.
the other is,
It's the standard deviation.
yes, standard
Okay.
deviation is 20. What sample size is necessary to make the standard distance between the sample mean and population mean equal to 2 points?
Okay, thank you. So it really repeated. Sample population versus um, just a sample mean value, which is aggregate sample, aggregate not one single case but multiple case versus a population mean. The distance, that is a standard error. Standard error, not standard deviation. So how you can find the standard error? Using standard deviation. Even like the population mean value, it's not necessary. Standard, let me go back here. Standard error is right here. Standard error is standard deviation divided by square root of sample size, right? So as the sample size goes up, your standard error goes down. So in order to have a standard, error value 2, what you need is basically you need standard deviation, which is a 20, and one number you need to divide to get a value 2, 100. And so square root of 100 will be, I'm sorry, yeah. So it should be 10. So 20 over 10, it's going to be 2. So square root of 100 will be the value. Okay. So again, what I'm asking you here is that the only matter about sampling error is all about the sample size. Once you have a standard deviation, only matter you need to consider is the sample size to increase or decrease those error term. All right, you got that? I'm sorry if just I ask you such a simple question. There will be really the questions you will be asked in your quiz, practice quiz, eventually in your exam. All right, right. So from there, there's my last slide. Just practice. This is some practice questions, and you can practice on your own from the back of the chapter, each chapter, and then let me know if you don't quite understand something, but only after you read the book chapter from 5 to 7 backward and for the first and then backward. Okay, so just practice that on your own. Okay, and then now I wanted to go. And so we have about 20 minutes, and because our sample, our data set we play with, it's a sample. Okay, and then usually those populations, population value usually do not really show how my sample population, look different from the population value, right? In reality, and they estimated. So just it's more of the foundational thing before we move on. So we from the general ideas of those, assuming those there's a our samples are closer to population, and then from there the statistical software use our sample statistics to predict calculating sampling error from that, and just make the statistical decision. But that's what they do. Okay, so let's wait to how they really use a different distribution table to do so with the real world examples or research questions. All right, rather than my sample versus population. We don't have a population yet, but we can compare. What about estimated population value versus estimated sample? And then how we can compare like male versus female population, or Republican versus a Democrat and versus independent. That's more of the real world statistics. So from that, let's actually go to our SPSS. I know you all downloaded. I know you all have that. We played GSS data on Thursday last week, right? So why don't you open up again ANS data set? So I wanted to show you something we will do right away in order to, you may, when you do literature review, maybe do some of hypothesis test, but you do not really need to turn in anything with SPSS. But eventually, while you are exploring the data, recording it, just make index variables, and those are something what you need. So that I will cover. So I will give, maybe let's have a 2 minutes break between now and then, and just pull out ANS data set from file under our Canvas website. But Grace, meanwhile, as long as you log in ANS, you got the data from 2020 anyway. ANS institution that you can download the 2024 data, right? So you can pull it out that from there as well. So I will wait. I already pulled it out. So I will wait a couple of minutes while you're ready for the. Sure. Okay. Sure. The small enough. And then this one. Or maybe I can share the whole screen. Okay. So me, I don't need to switch it back and forth to do anything. All right. So assuming that you see one of the screen on my computer, right? Okay. So now I pulled ANS data set. So I actually explore, and I know sometimes the even case number and corresponding variable because I played 2020 election data so much, but 2024 election data came out in 2025, so I don't know the variables. So I'm looking for variables for our practice each class session for each class session. So I pulled some of those variables yesterday. It might be it's a good list of a variable. Okay. So the variable I have here, so this is how I kind of find it and just kind of list it. It's a mess in my. They're asked for several decades over the time to sort of understand, you know, trust toward the government, trust toward things like that. But is there anyone who understand the differences between the theoretical, not statistical, but theoretical term between internal efficacy versus external efficacy? Anyone who understand the differences? As a master student, I want you guys to just have a little bit of a better clarification on people's, especially when you're dealing with the public opinion. Okay, public opinion and people's efficacy can be divided by internal efficacy versus external efficacy. So internal efficacy usually is if they ask how are you confident about what you know? Are you confident about who you vote for? Do you know enough? Right? So American voters, we have a sort of confidence on us. What we know, what we do is right. Am I qualified? Okay. Maybe today's problem is we are maybe too confident about what we know. Although those information out there we are getting is not really good information. Maybe we are too confident. There are a lot of things that really contribute to that. Information algorithm, for example, leads you some of the repeated information. Although that's not both the side of information, we are getting biased information. We are getting more partisan and variety of reasons. Okay, so that is the internal efficacy, and external efficacy is different categories. And ANS data set and GSS data set, they gradually build up the series of the question how we can measure external efficacy and internal efficacy. So, for example, here, all right, well, put it here. Let's see, it's a 24, 29. Okay, is it right here? So here, there are a series of questions. How often trust government, Washington, whether they are doing right thing? So if you say, yeah, I totally trust what the government does in Washington, high efficacy. And what about, do you trust our court system? Okay. And then what about the government? Just they do bears up for the public, not for special interest, right? So these are the series of the questions, okay, up to here. GSS data set and AS data set, they ask over, half a century, more than half a century, especially ANS data set near closer to 80 years. Okay. So these are questions, the series of questions, not only single question, series of questions asking their people's political external efficacy. So surprisingly, this series of questions predict a lot of things, their voting intention, voting choice, and political participation, any decision they make, and a lot of policy attitude. So it became sort of a solid prediction and good variable for us to use as independent variable. But here, today I want to just show you how you can make as index variable rather than this a separate question. You can make it as a one index variable as external efficacy. It will be solely there. predictor for your question, right? So, for example, here I still see there are all those missing cases that we need to code as a missing, but somehow do you uh, trust always means like if I trust always, it's a high efficacy, and never it's low efficacy. But they sort of reverse code it, right? So we wanna make sure always will be number five again by reverse coding. So higher value. So eventually you use this variable for some interpretation. So higher value means higher efficacy, lower value means lower efficacy. So we want to do recording. I will show you once again. And then let's see. Let's make sure this, I'm sorry, where is that? And the next one, go to variable. Same thing, we wanted to code those, missing values are missing. And then these values as reverse. And then the third one here, there are missing cases and we wanted to code, but look at here. Okay, so we wanted to decode, but run by a few business. Okay, so that means a low efficacy, and for still, benefit for all the the public. They should be okay. It's the right coding, but it's categorical. It's not really nomadic. That how we wanted to make index. So what you can do with this? What you can do with this? I prefer to leave one as one and two as five. Okay, so make it the same index variable. So I'm kind of like talking to you here. It's not absolute ways for you to do, but instead, what scholars they do to make index variable. Okay, so I understand that we cannot complete this. Okay, maybe we cannot complete this. Then I will just postpone the rest of the making index for the next class, next Thursday class continuously. All right, because next Thursday is also still part of the foundations that we don't have a specific statistical analysis we're gonna do, but we're gonna continuously, learn some of those skills to cleaning data. We'll continuously do. So don't worry, I'm not gonna hold you after class session. So that's what we'll code. Okay, here. And then so that's all what you can do. But is there any better idea for you how you can maybe just in order to make the index variable what you can do? Is there any better way for you to think about? So maybe you can go with your way, not my way. Yeah. But the best way I think about is okay. So there are limited and different scale, but at least make the scale as consistent scale. So when we make index, it's gonna be not bias any of those value. Okay, and then let's move on to the next one. And okay, now they have not 1 to 5, but 1 to 3, but waste a lot. It's a low efficacy, so it should be coded as number one as number one, and waste some. Maybe we can say 2 will be number 3. Don't waste very much as 3 as a number 5. So we can stretch that variable into scalable 1 to 5 instead. Okay, close. And then the next one, let's look at it. And then government, how many in government are corrupt? Okay, so all it's a low efficacy, and then none, it's pretty high efficacy. So we can leave that as it is. Okay. So it's a little confusing, right? So just how we want to make index, you need to go through every the single thing and making sure how we're gonna do it. All right. And then, so we're gonna leave this 1, 2, 3, 3 as the way it is. Okay. All of them are cropped. That is low efficacy, so we don't need to do reverse coding here. And then the final one here, no, actually there's two more. Actually, the one before final one, again, we need to recode them to how often can people be trusted? Always. In order to make the efficacy, external efficacy, always higher efficacy is a higher value. Intuitively, we want to do like a number 1 to 5 and never 5 to number 1. So we need to reverse code it, right? And then the election make it government to pay attention. Let's say a good deal. So it's like a high efficacy, right? So we want to make sure number 1 will be number 5, number some 2 will be number 3, and not much, and 3 will be number 1. So it will be same order with from the scale of 1 to 5. 1 is low efficacy, and number 5 is high efficacy. Okay, so that will recode. Recode. All right, and then so regarding the time, and I already I showed you how to recode, but just think about all these like data manipulation. In other words, better way and more optimistic ways, data cleaning process. So let's just think about it, and then Thursday next week we're gonna complete it as making one index variable. So I will stop here today, but before I let you go, okay, I want to show you again descriptive statistics here. If we go to frequency here, so whatever the variable, we got that. Last time we played with just whatever the value put it here, I don't know what it is. If you go to statistics, right, there is the central values and then variability. To remember, I was not able to click this because we didn't learn cover what is the standard error. But now we know standard error is reflecting sample size, not by only single case, but by sample size. So now we can click that and we can find the value. I don't know, just let's simply run whatever the variable is.
It's light.
So let's say it's a numeric variable, so we can run sample variance. So this will prove, might be a good one. Prove or disprove how college and universities are run. Okay, maybe a value. May I need to go back and think about it. But just the thing I wanted to show you is that here's a standard deviation. Okay, this is a standard error, and standard error is standard deviation divided by square root of sample size. Okay, so as like a sample size like a 5,500 sample size, you will see how much the error can get like shrink, right? So this is something you can see from random single case from the group of sample size will be this much effective. That's what we are dealing with from now on to the end of the semester. We are not dealing with the sample single case as you, but as group of sample, as one of the sample. That is the statistics. Okay, so I will stop here today. Thank you so much. Thank you so much for your attention today. Any question before you go? Yeah, otherwise,